Before I begin, this video is going to be quite short, but this project is very complicated, so if you want more information on a certain topic, you can pause the video whenever you see this icon in the top right corner. At that point, whatever text is on screen will have more information than what it is that I'm saying. But just to get a general understanding of the project, that is unnecessary. Alright, bit of background first. This is a mesophotic coral ecosystem, or MCE. There are a few around Hawaii, as well as the rest of the world. These are really deep down, around 40 meters is where they begin, so they're really hard to study, but are super healthy and have a lot of potential. Connected to that, this is a three-dimensional map of a reef created by a method called photogrammetry. To make one of these, you take a bunch of pictures, give it to a computer program, and you get a 3D map. They're super useful for studying reefs and conservation, but because you have to take so many pictures, they can be time-consuming and difficult to make. Because of that, very few have been made for MCEs. So that's the project then. Design and build a remotely operated vehicle, ROV, to descend to these reefs and create 3D maps of them. Quick design overview. This is the first prototype. It's designed around these two main enclosures that house all the electronics. They're rated to 100 meters depth, plenty for this project. It's powered by 5 thrusters, 2 horizontal, 3 vertical, giving it control in nearly all directions except for moving laterally. Attaching everything together is the frame, which is fully 3D printed. All parts are also small enough to fit on most 3D printers that are available on the market. In order to achieve the project's goal, this design has 3 cameras, one looking forward, one looking down, and one looking to the side for mapping, not including the internal camera for navigation. The control system is fully digital and based on commonly used open source software. Testing of the full vehicle was unfortunately rather limited. Only a few full function tests were performed. However, it was demonstrated to be capable of creating high-resolution photogrammetric maps of the seabed and descended to 15 meters, about 50 feet, depth with no issues. After basic function tests, in order to better understand and refine parts of the vehicle, testing was broken into 4 major sections: thruster improvements, structural improvements, mapping method selection, and hydrodynamic performance. That way, each of these can be more scientifically tested to find the optimal result. I don't have the time here to cover the reasoning, methods, and results for all 4, but you can pause the video at any point if you want more information. To summarize function testing, PETG was found to be the most structurally efficient material. The two-bladed propeller was the most efficient. The circle method of mapping was the most effective, and there are a lot of areas of poor hydrodynamic performance behind the enclosures and vertical thrusters. After testing concluded, a full second version of the vehicle was designed, mainly based around more internal space for cameras and battery capacity, as well as some hydrodynamic optimizations and other improvements. However, this was not able to be built in time. In the future, more comprehensive testing of the 4 elements that were tested here should be performed, as well as testing for other elements more relevant to the vehicle's operating depth, like pressure resilience and lighting. In conclusion, this project discovered the beginnings of the development of an underwater ROV for performing photogrammetric mapping on MCEs. Initial testing revealed that the vehicle was underperforming in some critical areas, although it was able to meet some of the requirements. Additional testing was then broken up into multiple sections to more scientifically test each individual component. While no vehicle was created that adequately meets all the design requirements, the testing that was performed can lay the groundwork for future iterations of the ROV. While this project may seem limited in applicability, the potential it could have is enormous and should not be understated. Easing some of the difficulties associated with studying MCEs could lift the curtain on a lot of the unknowns and mysteries surrounding reefs at these depths. Additionally, the maps it creates could be used to open up avenues of study as well as methods of conservation that were impossible beforehand. Looking even more broadly, the ROV also could be used for shallow water applications as well as numerous other fields. Alright, I believe that is all. Thank you for your time.